Okay, so want to move on to this topic today, the CDK framework, and we'll be using this right throughout the module. So we're laying the foundations today, I guess, but we'll be expanding on our use of the framework as we cover some other topics. For example, serverless, which is the next topic, probably next week, although I may get into it this week. Now, I'll just say that in relation to the labs, maybe from next week on, I'll turn up at the allocated room. But in a sense, attendance is optional in the sense that I'll still accept people submitting any queries that they have over Slack. Um, Either during the lab hours or outside of the lab hours. But as I said before, you may not get an immediate response outside of the lab hours. So I'll physically turn up from next week on, but I'm not attendance isn't mandatory. Right. So if we go into this section here, and this is all about infrastructure as code. Um, so I guess now, I just from some interaction with some of you yesterday, you've already started on this lab here. I actually hadn't intended people starting on it until I covered the topic. There's no problem pushing on ahead, but I think well, the first point, and I made this when I met you on day one, is you will need your own AWS account rather than the AWS account that you were using for DevOps last year. And as well, um, it's best practice, and I would recommend that when you're using the CDK framework, you don't log into your AWS account as the root user. It's better practice to create an IAM user, give that user the relevant privileges, and really there's only one. We're probably slightly over are adding too much privileges to the user, but create an IAM user and give that IAM user administrator access or administrator privileges. And for those of you that may have forgotten how to do that, this card here is just steps you through the process of how to create an IAM user. And if I flick over to, because I'm conscious of the fact that some of you are doing the cloud stream and most of you are not. So those that are doing the cloud stream would be very au fait with all of this, but those that aren't might be a little bit hazy about all of this stuff. But essentially, if I go over to my AWS root user, which is here. So here I am logged in now as my into my root user account. And what I am instructing you to do is to go into the IAM service, go into users. I'm not going to go all the way through this now because the lab steps you through it hopefully clearly enough. But if in my case, if I go into users, then for me, this is the account that I use when I'm doing any work essentially. As you may know, as you may remember and may have been told, I'm sure you were definitely told by Richard and Jimmy who taught the DevOps module, you should never use your root account for anything essentially other than checking what expenses you've been paying on the account. Uh, and outside of that, you should create an IAM user. So that's what I'm asking you to do, create an IAM user. And if I go into that IAM user in my case, And if I look at the permissions, well, I've given them a couple of permissions, but this is the key one here, administrator access. You will need those privileges in order to use the CDK framework. So that's that really. So if I go back to the website and if I go in here, as I said, this steps you through, hopefully in sufficient detail to allow you to do that. Having created the IAM user, you then need to generate an access key and a secret access key for that user, and you essentially install those locally on your machine using the AWS config command. But as I said, hopefully there's sufficient detail in what I'm showing you here to allow everybody to do that. And then from there on in, really, you'll be logging in to AWS using this IAM user. Are there any questions about that? No? Okay. Having done that, then you can launch into the lab. If you've started the lab already and you've been using your root uh, access key and secret access key, that's fine. But from here on in, I would go the IAM user route. So here are the slides that I want to get through this morning. So we're going to be looking at this CDK or Cloud Development Kit. It's a framework, as I said. There are two versions of it, but just make sure you're using version 2. I wouldn't say version 1 probably is even being supported anymore. And it's all in this area of infrastructure as code, and infrastructure as code. The idea is that you want to be able to describe in code the process of provisioning resources, specifically on the AWS platform. The CDK is specific to the AWS. There are other frameworks that work with AWS as well, but they tend to also work with other cloud platforms. But the CDK is specific to the AWS platform. And rather than just diving straight into the CDK framework and how to use it, etc., I like to kind of set the scene, if you like. So the context I'm saying here is that our goal as software developers, stroke DevOps engineers, our goal is to have a way that is reliable and consistent for provisioning and configuring infrastructure. And what we mean by that is, a reliable and consistent way of, let's say, setting up an EC2 instance or creating an S3 bucket with a particular configuration, or creating an IAM policy, whatever the nature of the resources. They're all kind of examples of infrastructure in the AWS world. But we want a way of doing that which is reliable and consistent. And why do we want to do that? Why do we want them to be, apart from the obvious, I suppose? Well, the answer is whatever set of resources or whatever infrastructure that we want to provision, quite often we want to repeat that a number of times. And so that's where the consistency comes in. We want to make sure that every time we provision this particular set of infrastructure, it will result in the exact same infrastructure being created for us. That consistency is really important, because the reality is, in a software engineering context, we may want to create or provision a particular infrastructure for multiple environments. We may want to create it for a development environment, or for an automated test environment, And certainly we'll want to provision it for a production environment. Now, we'd like those three environments, and there may be others. There may be something called a staging environment. It depends on the software house, really, as to what their software development process is. But for each of those environments, we want to ensure that it is the exact same infrastructure that our application code is running on top of. Otherwise, if problems arise during production, then we can't exactly replicate what the production's infrastructure looks like in a test environment or in a development environment. Also, in the case of AWS, as you know, the AWS cloud is broken up into regions. And so we may well want to deploy an application in different regions around the globe because our user base is scattered around the globe. So we want to be able to deploy our application across multiple regions. And that means we want to have the exact same infrastructure in provisioned in each of those regions. So the rationale for this reliability consistency is fairly obvious, I guess. The answer to that goal, though, certainly isn't to have some sort of manual provisioning process, because of all the problems with a manual approach towards this. It's not consistent because the person or persons that are doing it may have slightly different ways of doing it. They may end up with the same result, but they may not. That single source of truth point there, okay, you may actually document the exact steps that a person should go through to manually provision the infrastructure. But if we want to change that infrastructure, we have to go back to the document and make the changes there. And then there may be multiple copies of the document floating around an organization. And so there's no longer a single source of truth, and it just becomes unmanageable. The solution is to automate the provisioning of the infrastructure, and the kind of term that we use, or the label that we put on that, is infrastructure as code. In other words, we somehow describe the infrastructure that we want the AWS platform to provision for us. We describe it using code. And of course, hopefully, every time we run a piece of code, it does the exact same thing. Although that's not guaranteed, but the AWS platform does provide some ways of ensuring that. And the code hopefully is in a language that we are already familiar with, rather than it being a language that is specific to the provisioning of infrastructure. Although that's okay as well if the language is only specific to the provisioning of infrastructure, as long as the constructs and concepts of the language are easy to understand and easy to use, then it serves the purpose. So infrastructure as code allows organizations to automate and manage in a reliable and consistent way the provisioning of resources. And resources, for those of you that are kind of maybe a little bit unfamiliar with the language of the cloud, by resources, we're talking about, for example, an S3 bucket, an EC2 instance, an SQS queue, creating a specific VPC, so on and so forth. And the nice thing about it, so if we are going to write code that does this for us, then that code becomes our single source of truth. And also we can manage the changes that might happen to that code because we want to change the configuration of the infrastructure. We can manage that change in code using version control tools like Git and GitHub. So GitHub now becomes a very important part of this whole infrastructure as code space. And the great thing about a tool like Git and GitHub is that if we make changes to the code, and in our case now, this code is does what it does, and we run the new version of the code, and it doesn't work. It provisions the infrastructure incorrectly, or there are problems when we deploy the application on top of the infrastructure, and we want to go back to the previous version of the code. That's very easy to do with Git and GitHub. Um, so we have all those kind of benefits from version control. Also, by implementing code, then we can enforce best practice in the writing of infrastructure code and have patterns that we can share with people within the organization and share globally if you want to open source it. So I also kind of like to tell you how all of this evolved, even though, people as young as he may not be interested in how things evolved over time. So the very first infrastructure as code as an idea has been around for quite a while, maybe 20 years. The very first generation, or the first attempt at realizing this, I'm kind of depicting in the screenshot there, but you don't have to see the detail of the screenshot. What's on the left there? In fact, when I think about it now, he may have done something like this in the DevOps module. I meant to check with Richard and Jimmy, but on the left is just a Python script, and the Python script is using an SDK provided by AWS. If you might remember the Boto tree library, that I'm pretty sure. Can anybody confirm? Do you remember using the Boto tree library with Python in the DevOps module last year?
Yep.
Yeah. Yeah. So that's essentially what I'm describing here. Okay. That was the first generation of this infrastructure as code idea, that you write your Python script. It's using this Boto tree, which is the SDK, the software development kit provided by AWS. And you make essentially API calls to the various AWS services on the right. And so the API call might tell one of the services, might tell the EC2 service to create an EC2 instance with a particular configuration, or create an S3 bucket with a particular set of settings. And you run the script, and hopefully it works. But there are problems though with that approach, and the problems are the things I'm kind of listing here, like what happens if an API call fails? So maybe this script is running and the first few API calls work, but for whatever reason, maybe network problem, or the particular service that you're trying to contact isn't responding, or for whatever reason, an API call fails. That now means that some part of your infrastructure has not been created, and maybe even your Python script crashes. So some of your infrastructure has now been created and some of it hasn't. So you've got to manually go back and remove all the infrastructure that has been created, fix your Python script and run it again. And we're back to the manual part there that we don't like. The second point, how do I make updates to the infrastructure? Because invariably you will want to evolve the infrastructure. Essentially, you've got to write a completely new Python script. Okay, you may edit this Python script, the initial Python script, but you can't just run the Python script again, because it's going to create all the infrastructure, whereas maybe you only wanted to make changes to part of the infrastructure. So it's problematic, this approach, and the other two reasons are also part of the problem with this first generation. So it was great as a start, but you know, the problems were what I've been kind of outlining there. Now, uh, the AWS people and the other cloud providers, their response to this IAC objective from the DevOps perspective was to provide a service, which in the case of AWS is the CloudFormation service, but the generic name for that type of service is a resource provisioning engine. And so on the screenshot, the way this generation of IAC worked was, in the case of AWS anyway, you wrote what's called a CloudFormation template in either JSON or YAML. And that template described the infrastructure that you wanted. And it described what we call the state of the infrastructure. The state simply means the configuration settings for the various resources that you wanted within your overall infrastructure using JSON or YAML. And then you provide that template to, in the case of AWS, the CloudFormation service, and it then took care of actually communicating with the other services using the SDKs of those services. So, sorry, you no longer were concerned, you no longer were using the SDKs directly. The CloudFormation service was now doing the API calls to the various services in order to create your infrastructure. So that was fine. That's step one, to create your initial infrastructure. But the beauty of these resource provisioning engines was if you wanted to change the state of your infrastructure, maybe add some new resources, change the configuration of existing resources, what you did was you went back to your YAML file and you made the edits to that. And so your YAML file or your CloudFormation template, it now described the new state of your infrastructure that you desired. You provided that to the CloudFormation engine, and it worked out how to evolve your infrastructure into the new state that you desired. So it took care of updating your infrastructure for you based on you providing it with this CloudFormation template, which described, if you like, the desired state, new state of your infrastructure. And in addition, if while the CloudFormation service was making changes to your infrastructure, something went wrong, like maybe a particular resource configuration just didn't make sense, it would take care of rolling back your infrastructure to the previous state. So we have this idea that CloudFormation is able to move a set of infrastructure from the current state to a new state. And if there are problems in the new state, it will roll it back to the previous state. And this was one of the problems with the first generation. Essentially, you had to take care of rolling back infrastructure state, sorry. Now at the bottom, so these CloudFormation templates, as I said, you wrote them in either JSON or YAML. That JSON or YAML is now your infrastructure as code. Okay, it's not code in the conventional sense, but it still it describes it serves the purpose of describing the infrastructure that you wanted to have created for you or provisioned for you. Now there was another organization called HashiCorp. They also created this special purpose language called HCL, HashiCorp Configuration Language, which was an improvement on the templates, the CloudFormation templates. I think you wrote those in YAML or JSON as well, but they were better than the CloudFormation templates. There was sort of physically less syntax that you had to write, but it sort of served the same purpose. Okay, and I'm just kind of repeating some of the points that I've already made there, so I can skip over the disadvantages though with this with these CloudFormation templates is essentially, JSON or YAML is not really code in the conventional sense. It's really configuration. And the syntax is very verbose. And also you had to, in the template, you had to specify all of the settings that you wanted for your particular resource. There were no abstractions available to you. There were no kind of default settings. You had to be specific about all of the settings of a particular resource that you wanted provisioned. Hence, the CloudFormation templates were just very long and became difficult to read. Now, in this slide, I'm kind of summarizing what I've been talking about so far. So on the right there is a nice kind of, I think, and it's a nice kind of image describing how this whole thing evolved over the years. So first of all, the AWS people, they provided web API interfaces to all of their AWS services, EC2, S3. They provided an SDK together with these web APIs. That's what I'm saying on the top left there. These SDKs, sorry, now just give me 1 second. The SDKs enabled us to write our Python scripts, but we had the problems with that. Then the CloudFormation, our resource provisioning engine solution came about, and what was great about those engines was that they managed the state of your infrastructure. So enter the CDK are more generally kind of the third generation of this whole problem area. And the CDK, okay, was first released around 2019. And its idea, and if we look at the diagram on the right now, it simply is another layer on top of the resource provisioning engines. But what the CDK allows you to do is to describe your infrastructure state using conventional programming languages. Initially, it was only Python, but now there are a whole host of languages that you can use, and we will be using TypeScript. But we could have used any of the languages that are mentioned here on the left, and there are many, many others, all the way up to, the Rust language, if you're familiar with Rust, which is a new language on the scene. You can use that together with the CDK framework to describe the state of the infrastructure that you want to have provisioned for you. And the CDK framework, it has loads of classes. It has a large class library. And the nice thing is that when you create instances of particular classes in your code, there are kind of sensible default settings for whatever particular piece of infrastructure you want to have provisioned. So you physically have to write less syntax using the CDK framework as opposed to the CloudFormation templates. So I'm saying there's a better developer experience in the sense that your IDE provides lots of IntelliSense and hinting to you, as we'll see. There's physically less lines of code when you compare the CloudFormation templates versus the CDK code. You can do automated testing of your CDK code, but we won't look at that. So from a concepts point of view, it's quite similar to the language of CloudFormation, I suppose. Not surprisingly, because it's built on top of the CloudFormation resource provisioning engine. But we talk about applications. Now, an application in this case doesn't contain any functionality as such. It's the purpose of the application is the provision of infrastructure, but we use the term a CDK app. We talk about a CDK app or a CDK application. And a CDK app is comprised of one or more stacks. In the main, we will only have one stack per application. And a stack is a term that you would have used when talking about the CloudFormation service in DevOps last year. A stack is comprised of constructs, which is a CDK idea concept, and a construct is comprised of one or more, typically more anyway, resources. So resources is down at the lowest level. A resource would be a single S3 bucket, a single IAM policy. A construct could be a combination of a number of resources. And the diagram down here kind of visualizes the relationship between these four terms anyway. So you have the application at the highest level of abstraction. It is comprised of one or more stacks. A stack is made up of constructs. A construct may, the execution of a construct will create a number of resources related to particular services. And when you run a CDK app, again, it's the same as before, really. It communicates, well, sorry, when you run a CDK app, it actually generates the CloudFormation template. Because at the end of the day, we are going to be using the CloudFormation service to do the heavy lifting for us. And the CloudFormation service only understands CloudFormation templates, that YAML and JSON stuff that I was talking about a few slides back. So whereas we write our infrastructure provisioning in TypeScript in our case, using these concepts, when we run that application on our desktop, it generates the CloudFormation template. The CloudFormation template is provided to the CloudFormation service, and it does what it always does. I'm saying a stack is a unit of deployment. So deployment, we know what that terms mean. Deployment here now means you're creating the infrastructure. We also use the term deployment in relation to functionality, but not in this case. Deployment means you're initiating the creation or the updating of a set of infrastructure. All I'm showing you here relates to the kind of improvement in developer productivity stroke developer experience. Like on the left, I'm showing you a small piece of CDK code, which we'll look at in a few moments. But that CDK code, which roughly has 12 lines of code in it, the equivalent CloudFormation template has, what am I saying, 150 lines of code. That's probably slightly over the top. But it's certainly, the relativeness is close enough anyway. Hence, you've just got physically less typing of syntax to do using the CloudFormation, the Cloud Development Kit. And so this is kind of what I was describing there a few moments ago. So as a developer, you describe your infrastructure using a high-level language, in our case, TypeScript. You then get the CDK framework to kind of run this TypeScript, and it generates the CloudFormation template. That CloudFormation template then is consumed by the CloudFormation service, and it then talks to the individual services that are relevant to your infrastructure using the SDK. The CloudFormation service is actually using the SDK. These are API calls, but it's using the SDK to make the API calls. And the individual services then, they take care of creating the actual resources that make up your infrastructure. And that was always the case. So really kind of from here on, nothing has changed, right? it's this part over here. So this here that is new in the IAC context. And so this is kind of your typical workflow. You create a CDK project, and I'll show you the structure of the project in a moment. You do need to tell the CDK framework which language are you using, because that will obviously influence the initialization of the project. You optionally can run the CDK synth command. Synth is short for synthesize, and what that does is it creates a CloudFormation template locally, but it doesn't kind of execute the template, if you like. We don't actually use that command at all hardly anymore. The CDK deploy command, that the effect of that, if I go back to here, I'll just erase all that stuff. When you hit CDK, when you type the CDK deploy command, you're essentially now uploading your template to the CloudFormation service, and it executes the template, i.e., you are deploying your infrastructure. You then may, at some stage later on, you may want to change your infrastructure. So you go back to your project, your source code, if you like, and make whatever changes you want to. And you just run the CDK deploy command again. But this time, the CDK deploy command will realize it doesn't have to create a new CloudFormation template. It has to make changes to the initial CloudFormation template. It does all of that behind the scenes anyway. So it updates the template and sends that updated template to the CloudFormation service. And the CloudFormation service is clever enough to work out what has changed between this new version of the template and the previous version, and make the relevant SDK calls to, or web API calls to the various services to make changes to whatever infrastructure they currently have provisioned, or create new resources, depending on what kind of changes you carried out up here. The CDK destroy command tears down all of the infrastructure. So one simple command, and that will take care of deleting all of the resources in an organized fashion. But again, that is taken care of really by the CloudFormation service. It's not so much the CDK framework. It just sends the instruction to the CloudFormation service to delete all of the resources related to a particular stack. So that facility has always been there. On the right, I'm showing you the structure of a CDK project, and there really is only one place that we will do the majority, in fact, if not all of our focus will be on the lib folder. That's where we create TypeScript files. Each TypeScript file will describe a stack. Remember, a CDK application is comprised of one or more stacks. So you would have a stack file in the lib folder, a TypeScript file in the lib folder for each stack. And the code within the stack then describes the infrastructure that you want to have provisioned. In the bin folder, there's a single file which we very rarely need to go near, but that's kind of the entry point for the CDK framework. You could think of this one here as being a bit like main in Java, right? And all that happens inside in this TypeScript file is it creates an empty CDK app, and it adds whatever stacks are down here to that app, and end of story. So there's typically only 2 or 3 lines of code within this file, and we rarely have to change that file from what was created initially when you created the project. Like I'm saying, look, there is a test folder down here, and you can write code that tests your framework, but it's not as straightforward as you might think, and we don't need to go near it anyway. We don't have time to do it. If I go back to here, okay, an application is comprised of stacks. A stack is comprised of constructs. Now, there are three levels of constructs. L1, L2, and L3. An L1 construct has a one-to-one relationship with a CloudFormation resource. Okay. So you might have an L1 construct to create a particular resource. It could be, I don't know, a an IAM policy maybe or something like that, just a standalone resource. We don't have many L1 constructs that we need to use. We mainly use L2 constructs. And an L2 construct, when you create by I suppose construct here now will really translate into object instances in an object-oriented sense. There'll be a class provided by the CDK framework for L1 constructs. There'll be classes provided for L2 constructs. So you'll just be creating instances of those classes in your code. But when you create an instance of an L2 class, and we'll see examples in a moment, then when that instance gets translated into CloudFormation template language, it actually creates a number of resources. So there's a one-to-many relationship between an L2 construct instance and a CloudFormation resource. And of course, the beauty of that is that, that's why there's less code that we have to write. If the only kind of constructs we had were L1 constructs, then we'd have to write an awful lot of code in order to create our infrastructure. And the L2 constructs, typically, they create a collection of resources that are typically go together and are related to each other. There are also L3 constructs, which I don't think we come across any L3 constructs, but they kind of build up. An L3 construct typically implements some best practice pattern in the IAC world. And the L3 constructs are mainly provided by the open source community. The CDK framework itself provides L1 and L2 constructs. It may have some L3, but the majority of L3 CDK constructs that are out there were provided by the open source community. And I'm sure there are good ones. I've never bothered to look around for them. Better that we deal with just L1, L2. So a demonstration, although you can ask questions if you want to, from what I've covered so far. Okay, here I have a CDK project, and it has that structure that I showed you. So it has the bin folder and the lib folder, and they're the only two, as I said, that we're really interested in. If I look in the single file that's in the bin folder, and they're all written in TypeScript in my case, all that's happening is it's creating an empty CDK app. Here it's creating a stack, and the stack, now I know I did say to you that when I was talking through TypeScript, I was saying TypeScript supports classes, but we don't really use classes hardly at all. This is the only place where we do use classes, but from here on in, we won't be using classes at all. So I'm creating an instance of a class here. The class is actually this guy down here. So I'm creating a stack because that's what this describes, which we'll look at in a second. Creates a stack. I'm creating a stack, and I am associating the stack with the app. I'm essentially connecting the stack to the app, because we said an application or an app is comprised of one or more stacks. And that's it, really. That's all that's in the bin folder. So when we run the CDK deploy command, the very first file that it will look at is this file, and then it'll build up the CloudFormation template based on that. So, and again, as I've already said, we actually rarely need to come into this file to make any changes to it. So here's the file that we're interested in, and this is the one that has the most stuff going on in it, although there's very little. All I want to do in my stack is I want to create an EC2 instance and just link that instance to my default VPC, and that's it. So, there's very little infrastructure that I want to have provisioned, but still there's enough to just get us started. So in order to code a stack, you have to create a class. I have to get rid of that mouse over stuff that's happening because it's very annoying. You create a class, call it whatever you want to, but it has to extend the stack class. And the only method that you implement in this stack class is the constructor. We actually, there might be one occasion where we implement some private methods as well, but there are no public methods that we need to implement. So even though we're extending a class provided by the CDK framework, the stack class, the only thing that we actually implement in our stack class is the constructor. And so the constructor signature is always this, and we can just kind of ignore it for now if that's okay. Okay, we call the stack classes constructor. That's kind of boilerplate for now also. And here's this line of code. You kind of almost work it out. What I'm doing in this line of code is I'm getting a reference to the VPC that has been created for my AWS account. As you know, when you create an AWS account, a VPC, or a virtual private cloud, is created specifically for you, and that becomes the default VPC. We won't be doing anything with VPC after today. In fact, we won't be doing anything with EC2 after this week. But just to remind you, when you create an AWS account, a default VPC is associated with that account, and I'm just getting a reference to that default VPC for my account. So this is going to have a reference to it. And what am I doing here? Here it looks like I'm creating an instance of an EC2 instance. Okay. And of course, I'm importing some stuff as well. So I'm importing the AWS CDK lib, which is, of course, by the way, this is a Node project. And if I look in the package.json, then from a dependencies point of view, the dependencies is essentially the main library that comes with the CDK framework. And this is what I use this is where we will find the L2 constructs that I was talking about. There are other parts to this library as well, but for this particular project, this is the only one that I need. This is a standard dependency that all CDK projects will need. And equally, this is a standard dependency that all CDK projects need. The dev dependencies, mainly what I'm doing here is I'm importing, or I'm pulling in TypeScript type declaration files. Remember these .d.ts files? I'm pulling those in because they may be useful to us, although I think I don't actually use them. I certainly don't use this one, so I could have removed that. This one is probably being used. I don't really need that either. Jest is a testing library, and we're not going to be looking at testing, so I could have left that out. And this is the again, related to the testing. So most of these we don't actually need except that one. But in terms of this one here, if I go back to my stack file, I'm importing from a particular part of the library, this part here. The library is broken up, the library covers all of the services, but in this particular stack, we're only interested in the EC2 part. So I'm just importing from that part of the library. And here's where I'm using it. I'm creating, essentially, I want to have a new EC2 instance provisioned for me. Now, okay, you'd have to look at that mouse over stuff is very annoying. One would have to look at the class, the EC2 instance class, to know what parameters to pass to it. You won't need to do that though. I'm just giving you this code, and most of it makes sense by just kind of scanning over it, or makes a certain amount of sense. But every resource that you create, you have to link the resource. Sorry, every construct that you create, you have to connect that construct to the stack. And this there is referring to the stack. This is referring to, if you like, the parent class, and the parent class is a stack class. So here I am creating an EC2 instance, or a construct that will provision an EC2 instance. It will also provision some other resources like an EC2 instance profile, which is another AWS resource related to the EC2 service. That's created kind of behind the scenes. Remember I said that an L2 construct creates a number of resources. Clearly, in this case, it creates an EC2 resource, but it also creates some other resources that are used by EC2 instances. And we don't have to worry about the detail of those. They're pretty standard, and we can take the default settings for those other resources. You have to give every construct a name, just an arbitrary name. So, oh, sorry, beg your pardon. Sorry, I'm on the wrong one. Sorry, I should be on this one here. So again, this refers to the stack. You've got to give every construct a name. It's just an arbitrary name, although it does have to be unique. So that's the name that I've chosen. And the rest then is the configuration for this particular resource. And again, just take it as read rather than needing to know what are the various settings that would be associated with EC2. But if you kind of scan over this, it looks like what I'm trying to create is an EC2 instance that is based on the Amazon Linux 2 operating system. It's a T2 micro instance, if you remember the various types of EC2 instances that you can create. T2 micro instance is a pretty low scale instance. And any of the other values, so there's our Amazon Linux instance, Amazon Linux. Does it mention T2 micro? Well, it's not a T2 micro, as it turns out. It's a burstable image, but I wouldn't worry too much about these settings. Now, I have commented out this. That mouse over is terrible. I've commented out this line here, and we'll come back to it because I've got some other code down here that's commented out as well. So my stack is comprised of just one construct, the EC2 instance construct. And I want to provision this stack, or I want to deploy this stack to the cloud. So I've already ran npm install now. I think that is red. And if I just go CDK deploy, and hit return, just checking now, do I need to, I think I can just go for it. So CDK framework now is taking my code. It's looking at the file in the bin folder. That brings it to the stack in the lib folder, and it's creating the CloudFormation template behind the scenes. It's also, in particular, paying attention to any permissions that my stack may require, and it's kind of summarizing them here. We can kind of scan over that though, and it's asking me, are you okay with deploying this application, i.e. getting the resources provisioned? And I go yes, and it now starts the process of sending the CloudFormation template up to the CloudFormation service, and the CloudFormation service will keep us updated. You can see here it's creating some resources. The CloudFormation service keeps us updated on the progress that it's making. Now, while that's going on, I'm going to stop sharing for a second, and I'm going to log into my IAM user account that I was talking about there, where these resources will be located. So I'm just going to stop sharing. Can somebody just confirm now that my screen is back online again?
Yes, it is.
Okay. So it went through its process, so it looks like everything was successful. And if I now go over to my AWS account, we can poke around a little bit. If I go into the CloudFormation service, here we go. That's CloudWatch. Then we've got a couple of stacks here, but I can tell you this is the stack that's related to my application. How do I know that? If I go back to the code, and if I go in here, I did say that's the name of the stack. So that kind of corresponds to that. This stack here, um, in order to use the CDK framework, you've got to bootstrap your account. And I explain in the lab the steps that you have to go through to do that. And having bootstrapped your AWS account, you will see a stack called CDK Toolkit. Okay, and that's used behind the scenes by the framework together with the CloudFormation service. And so don't ever delete that, because if you do, then, well, you essentially have to bootstrap your account. And just by the way, so we will be doing everything in the EU West 1 region. We'll be deploying our stacks only to that region, just for convenience. But in general, if you want to deploy a CDK stack to other regions, you have to bootstrap for each region that you want to deploy a CDK stack to. That's just by the way, doesn't apply to us though. So here's evidence that our CDK app has been deployed, because it was only comprised of one stack. There's only one stack here, but if it had multiple stacks, they'd all appear here. And it looks like everything was successful. Now, in our case, if we go over to the EC2 and to the EC2 console, probably should have shown you this before we did the deployment and see the look at the before and after, and in the instances, uh, this is the CD the EC2 instance that it provisioned for me. It's currently running. The other one is just an instance that I used for other purposes, and you can see it's not running anyway. If I go into this, if I select this instance, and in particular, if you might remember from DevOps last year, each EC2 instance, amongst other things, has a security group associated with it. That security group controls the various ports that are open, both inbound and outbound. Now, even though there is nothing in our CDK code about creating a security group, that's another example of a resource that is part of the EC2 instance construct that we coded in our stack file. Although, and those other resources, they will have default settings associated with them. Now, for something like a security group, the default settings would probably, well, let's look at it. If I go down to security, and if we go through, as you know, it creates a security group for each EC2 instance. That's just AWS policy. And it looks like there is an inbound rule, okay. Or is there? No, there's no inbound rule. Is there an outbound rule? There probably is a default outbound rule. Yeah, there is an outbound rule which allows all outward communication to happen, but critically, there's no inbound rule. So our EC2 instance is secure from that point of view anyway. But supposing I realize I actually want to open up some of the ports associated with this EC2 instance. In other words, I want to update the state of my stack. So I go back to my CDK application. And let's supposing I want to open up the SSH port so that I can SSH into my EC2 instance. Again, I'll just, I'm just going to give the code. So here's the code that will do this for me. In general, you don't have to, the code doesn't have to be written in a certain sequence, but just for this particular case anyway, if I enable this line here, this is how we configure a custom security group for an EC2 instance. So there's a property called security group, and you point it at a security group instance. That is referring to this variable here. So just from pure coding point of view, you cannot refer to a variable that's lower down in the code. So if I just simply move this up above it, then it will resolve that TypeScript error. It's just a TypeScript error is all I'm getting here, really. You can see, so if I just move that up, I could move all of it up actually, even though, so here's an example of creating a security group. Again, okay, we'd have to look at this class to work out what parameters it needs, but the first two parameters are the same for all constructs. The first parameter, you've got to tell the CDK framework, what are you linking or connecting this construct to? And in our case, we want to connect it to the current stack. So that's what this refers to. This is just the name that I want to, or label that I want to give to this construct. Yeah. And in the case of a security group, okay, there are some settings that I seem to be doing here. And again, I'm not going to go into the detail of them, but it's fairly obvious what it's trying to achieve. It's connecting the construct to the default, it's connecting the security group to the default VPC associated with my account. And it looks like I want to open up all outbound traffic from my EC2 instance, which is similar to the default actually. But here's the important or the real change that I want to effect. So I'm just adding a new ingress rule to my security group, and this ingress rule, if you just scan over it, looks like it's opening up uh, port 22. So I've made changes to my infrastructure, and all I've got to do is run CDK deploy again, and the CDK framework in conjunction with CloudFormation will take care of updating the state of my stack. Now, certainly these stack changes have impacts from an overall application security perspective, and the CDK framework. Did that run? I don't know where that came from. Did I run CDK deploy? Okay. So it has noticed that you are making changes to the security side or permissions side of your stack. So it is asking me to confirm, am I happy with the changes that will take effect? Again, I'll say yes in this case. And it's now creating the updated CloudFormation template, sending it up to the CloudFormation service, and the CloudFormation service will keep us updated on the changes that it is carrying out. If we now go back to our console, and from memory now, it just creates a completely new security group rather than updating the existing one, as far as I'm aware. So we need to do a couple of refreshes to make sure we see the new one. It'll be obvious anyway, but as you know from last year, you do sometimes have to wait a little while before these things follow through. So again, when I look at this one, it may still be the old one. It's the inbound rules that we're interested in. And yeah, it looks like we've got our new inbound rule for SSH port TCP. So that's kind of just a simple little illustration of updating the state of a stack. You just change the source code and CloudFormation, and the CDK takes care of the rest. Just pause again if there are any questions so far. Now, while you're considering asking a question or not, I know now, I'm just kind of skimming over the code. I'm not really stepping through it in any kind of great detail. There's not a lot of code. Um, there's not a lot of code in the stack itself. And I did say, and the reason I'm not paying a whole lot of attention to the detail of it is because we won't be using EC2 really from here on in. But aside from that, really, we're just creating objects from classes that come with the framework. We're configuring those objects. Sorry, just bear with me for a second. Okay, sorry about that. Bit of an interruption there. Let's get back to the stack file. So what I was saying there is I'm kind of skimming over the code. I'm not explaining it in detail for two reasons. One I've already mentioned. This particular code is all about EC2, and we won't really be using EC2 from here on in. But at a very general level, what we're doing, for example, here and here, is we're creating instances of constructs. Constructs is our CDK term. The one that I've highlighted is definitely, I think both of them are probably L2 constructs. Possibly this one up here is an L1 construct. These constructs come in the form of classes, and all of the classes, irrespective of what type of resource or construct that you're using, they all have the exact same signature, as it turns out. And the signature is the first parameter is what's referred to as the scope of the construct, which translates into what do you want to connect this construct to, which almost 100% of the time you want to connect it to the current stack. The second argument is just an identifier for the construct, and that's just something you make up, although they have to be unique within the stack for obvious reasons. And the third argument is always a JSON object, and the specific properties of the JSON object are particular to the type of construct that you're creating. So the ones that I've highlighted here are obviously specific to the EC2 instance construct. Yeah. And that pattern is going to be repeated right across all of the CDK code that we're going to be writing. And that's the only kind of detail that you need to take from this code that we're looking at here. Like if you're really, really, really interested, what you can do is if I mouse over it and click through, then it's opening up like a file for me. And if you look at the name of the file here at the very top, you don't get all of it actually. But what we're looking at here is a .d.ts, which is a TypeScript declaration file that the CDK framework provides to us, which contains sort of detailed documentation, if you like, on that particular construct. I don't see needing to have to go into that, but if you're really interested, you can drill down into the full detail of a particular construct and what are the various properties that you can control when you're declaring an instance of that construct. By properties that you can control, I mean, these guys here. Now, for this week's lab, I jump over to there. Oh, yeah, sorry. Just before I do that, sorry, let's go back to here. An EC2 does cost money the longer you leave it up and running. And certainly we don't want to be doing that. We don't incur costs. So I want to, as we say, tear down my stack. And to do that via the CDK, then I simply type the command CDK destroy. And that now, again, will send the direction up to the CloudFormation service. And the CloudFormation service will do its thing. It will look at the template, the most updated version of the template, which it has stored above, coincidentally. And it will remove the various resources that have been provisioned in an organized way. And it's clever enough to know the order in which it should remove the resources, because there are dependency relationships between the resources that you have provisioned, but you don't need to know about the dependency relationships. CloudFormation understands them, and so it's now going through the deletion process. We might just let it work its way through, and then if we go back to our web console and just look at, let's say, these two instances, we'd see that it has been terminated. And we'll just let it work away and we'll come back to it. This week's lab. You're actually going to be creating arguably a fairly sophisticated or provisioning a fairly sophisticated set of resources. You're going to be provisioning an application load balancer, a EC2 instances that are going to be contained, that are going to have a security group associated with them. There's going to be an auto scaling group that is going to manage the creation and termination of this set of EC2 instances. You might remember this architecture from DevOps again. I think you would have created this architecture perhaps at the end of the DevOps module last year. And also the EC2 instance in this case is going to be hosting a simple web server. The EC2 instance that we created in the demonstration isn't really hosting anything, but in this case, these EC2 instances will be hosting, I think it's an Nginx web server, it could be an Apache web server. And the application load balancer, as you might remember, its role is to balance the load of traffic that's going to your set of EC2 instances. And so from the browser, you'll be able to, what the stack is going to actually, when you create the stack, what it will return back to you is the domain name of the application load balancer. Then you can go to a web browser, use that domain name, and just hit repeat a number of times. And so the application load balancer will send a request to this EC2 instance, it'll send the next one to this one, and it'll load balance between them. And in the HTML response that comes back from the web server, it will include the IP address of the EC2 instance. And so that will appear on the screen of your browser, and you will observe like that you're getting different IP addresses every time you kind of refresh because of the load balancing that's going on. So from an architecture point of view, I would argue this is a sophisticated architecture, and I'm just giving you the code to create it. You can, again, skim over it, but you don't have to go into it in any kind of understand it in any great detail, because as I've mentioned too many times now so far, we won't be using EC2 at all from after this week. I would warn you though that make sure you destroy this stack. Try to create it in one session, if you like, in one lab session, whenever you do the lab, and then destroy the stack at the end of that session. Otherwise, you'll be charged for all of this infrastructure, even though it's lying idle. Let's go back to see, did my stack. So it looks as if it has done its thing. And if I go back to the management console, where's my management console? Go into EC2 part. And yeah, it has terminated the EC2 instance for me. Okay, again, I'll just pause in case there are any kind of initial queries that you might have, be it at a very general level or specific to this particular piece of code. Probably not, I'd say. Maybe more at a general level. Do you understand, do you get the basic idea behind what we're trying to do here?
Yep.
Yep, okay. Where do we go from here? Let's see. I go back to the module website. So I've introduced the CDK framework, and we've demonstrated it to provision an EC2 related stack. The next topic I want to move on to is the whole serverless model, serverless architecture. I'll just talk a little bit about this, but I won't go into any detail today. And I'm sure you've heard the term serverless before. So just at a concept level, and we will spend maybe 2-3 weeks on this now with quite a number of labs, and that will be the basis for the first assignment. So if we go into the slides behind this card. So I would imagine you know this already about serverless. Serverless does not mean that there are no servers being used. EC2 is an example of a server in the AWS world. So serverless, if you're deploying an application in the more conventional sense of the word application now that has functionality in it, okay? If you're deploying an application to the cloud, the old-fashioned way of doing it is you would deploy it to servers that are running in the cloud. In the case of AWS, EC2 servers. And the problem with that model, though, is that even if there's very low usage of your application, you're still being charged for those EC2 servers that are sitting there doing nothing. So it's not very cost effective from the kind of AWS customer's perspective. Hence the serverless model came about. But serverless does not mean that there are no servers being used. There has to be servers somewhere hosting your application functional application code. The point of serverless is, though, that you are not responsible for provisioning those servers, and you're not responsible for maintaining them. Hence, you don't have to create EC2 instances as part of your infrastructure. That's all. That's the kind of opening line about serverless. Doesn't mean there aren't any servers being used. All it means is that you, the developer, you're not concerned about provisioning them, maintaining them, managing them, starting them up, shutting them down, etc., etc. Sorry, there was another interruption there that I had to mute myself for a few seconds. Okay, so without the serverless model, though, which is fairly ubiquitous right now, these are all the kind of issues that, as a developer stroke operations person, that you were concerned with and had to deal with. And I won't go through them. They're all fairly self-explanatory, I hope. Screen they're hopping. So without serverless, these are issues that you had to deal with. With serverless, though, with the serverless model available to us, there's no servers that we have to provision, as I mentioned. You don't have to manage them. The whole area of scalability, you don't have to worry about either. Scalability, coincidentally, in the server centric model, was all about application load balancers, etc., which coincidentally happens to be what you're setting up in this week's lab. But application load balancers, as you know, you need to configure those to deal with the scalability side of your application. But in the serverless world, scalability is still a really important issue, but you actually don't have to concern yourself as much anyway with scalability issues in the serverless world than in the server-centric world. The infrastructure that we'll be using the infrastructure that we'll be provisioning, the serverless infrastructure that we'll be provisioning, is automatically tuned to handle scale, as in if there's suddenly a burst of traffic hitting our application, the infrastructure will scale up. And when that traffic starts to taper off, the infrastructure will start to be removed. That kind of happens automatically. And we'll see examples of that when we start looking at the particular serverless services that are provided by AWS. Also, the third bullet point there, really important, in the serverless infrastructure model or architecture, you only pay as a customer for the amount that those services are being used. If they're lying idle, you're not charged. Also, availability and fault tolerance is built into the serverless. Availability and fault tolerance is a really important part. You don't want your applications certainly to be not available to your end users. And the way you kind of deal with that in the server-centric model is you replicate your application across maybe different regions, certainly across different availability zones, but you kind of have to deal with all of that. In the serverless world, you don't. It takes care of it for you. It won't take care of multi-region serverless. You do have to do a certain amount of work in that context, but an AWS region, availability and fault tolerance is kind of built into it. And again, we'll kind of mention that in passing as we start to look at the services. So it's all good from the developer's perspective. Greater agility, uh, less overheads, increased scalability, and so on. This is a nice graphic. Maybe I'll finish on this one for today that I found, which kind of shows from the developer's perspective where their focus has shifted over the years. Initially, developers had to be concerned with everything. They had to be concerned with the actual physical hardware and the configuring of the hardware. Then, when virtualization came about, okay, they were removed from being concerned about physical hardware, but they did have to concern themselves with configuring and maintaining your virtual machine instances. That's kind of the previous generation. Now in the serverless world, all we're concerned with is the actual functionality, the actual code itself. Well, sorry, okay, let me just get my pen. Uh, After virtualization came containerization. I don't know if you're familiar with the Docker platform or not. It's kind of another form of virtualization. But where we are now is in what's called the kind of serverless or function as a service world, where the developer only concerns themselves with the functionality of the application that they want to develop, and the underlying infrastructure takes care of all of the other kind of messy stuff, uh, like scalability, availability, fault tolerance. It takes care of all of that automatically. So the developer's focus is purely on the functionality that they want to develop. Right, I'm going to halt it there, and we'll pick it up from there next week, and we'll start looking at the serverless services that AWS provides. And we're going to start with, having looked at the kind of high level stuff, we're going to start to look at the AWS Lambda service, and we'll have a few labs on implementing Lambda-based applications. And as I said, that will be part of the first assignment, which admittedly now is a couple of weeks away, really. Okay, apologies for the couple of interruptions that occurred there, but these things happen. So if there are any questions, I can certainly hang on for any questions before we wrap up. So in terms of labs, this week, focus on the CDK lab, but create your IAM user first, and then use that IAM user whenever you're logging into the AWS Management Console. Also configure your AWS CLI to use the access key and secret access key of that AWS IAM user rather than the root user credentials. Right, I'll talk to you next week. Bye for now.